Okay, I'm going to talk about a volume of a rotation between two graphs. And so what I mean is this. What happens if you take this region and rotate it around here? I'll come back to that, but that's the topic. But first I wanted to review the basic idea. We saw on class on Thursday that if I take this region right here between A and B and rotate it around the axis, I get a solid, and this is the volume. And really what's going on here, and this is always true when you have a volume of a rotation, is that volume is pi r squared dx. So you need to figure out what r is. And in the above, it's pretty clear. R, the radius of the disk, is that. Because when you rotate that around, you're going to get a disk that looks like this. And this piece right here is r. So that's just sort of if I take a side view like that and then put it on the bottom, look at it from the top, that's what I get. So what's r in the above? Well, r is just equal to the function. So r is equal to f of x. So that's why in this integral, volume is pi r squared x dx. So that's the key idea. Okay. So to the problem at hand, we're finding the volume of a rotation of a region between two graphs. So in other words, we're looking at something like this. And this is, again, the side view. This is going to be a washer. The washer will come out right at you. So I'm taking that and flipping it over. So we get kind of a side view from the top. And the bottom curve is G. The top curve is F. So always we have this formula. Well, volume is pi r squared. Well, what's r? Well, what's r is going to be is the top minus the bottom. And that's going to be f of x minus g of x. Okay, and so that would mean that my integral, here we'll get to that in a second, my integral is going to be volume is equal to ab pi r squared x dx. That's going to be ab pi f of x minus g of x squared dx. So if you square that out, you're going to get ab pi f of x squared minus 2f times g plus g of x squared dx. Okay, that's the theory. So again, when I look at this, I got to figure out what r is because I know that formula is always true. This distance right here is r. That's the radius right here of the washer, and the radius is top minus bottom. So kind of another way to look at that, this is the same idea, and is to think that the top is a radius 1, the bottom is a radius 2, so the radius is equal to r1 minus r2. That's the top function minus the bottom, f of x minus g of x. So you can think of it in two different ways. Top minus bottom, r1 minus r2. That'll give you the radius. I hope that makes sense.